Hello students, welcome to this lecture on statistics. In this lecture, we will discuss NCERT exercise 13.1. This is disclaimer. First of all, we will discuss NCERT exercise 13.1. So let's get started. This question asks us to find the mean deviation about the mean for a set of numbers. The data given is 4, 7, 8, 9, 10, 12, 13 and 17. So students, first of all, try it yourself. So the question is to find the mean deviation above the mean for the given below data. So we will solve this question step by step. We have given that the data is 4, 7, 8, 9, 10, 12, 13 and 17. Now, let's recall the formula for the mean of a data set. The mean, often written as x bar, is calculated by adding up all the data points and dividing by a total number of data points. That is, mean equal to summation xi, I equal to 1 to n divided by n. Here n is the total number of data set, okay, data points. Then x bar, this is equal to 4 plus 7 plus 8 plus 9 plus 10 plus 12 plus 13 plus 17 divided by 8. Since the given data is 4, 7, 8, 9 and so on, and number of data points is 8. Okay, so x bar, this is equal to sum of data points divided by total number of data points. So sum of data points is 80 and total number of data points is 8. So x bar equal to 80 upon 8, and this is simply equal to 10. Next, we need to find the absolute deviations from the mean. That means we subtract the mean from each data value and take the absolute value or the positive difference. Okay, so we will write it as absolute deviation xi minus mean, and here the absolute values of deviations from the mean x bar are, so the absolute deviations for 4, okay, about the mean 10 is absolute value of 4 minus 10 is equal to 6, and absolute value of 7 from the mean x bar equal to 10 is mod value of 7 minus 10 equal to 3. Okay, and similarly for 8 is mod value of 8 minus 10 is 2. For 9 is mod value of 9 minus 10 equal to 1. And you can list for the remaining data points for 10, 12, 13 and 17. So first, let's recall the formula for mean deviation about the mean. It is written as mean deviation about the mean x bar is summation I equal to 1 to n absolute value of xi minus x bar divided by n. The sum of the absolute differences is 6 plus 3 plus 2 plus 1 plus 0 plus 2 plus 3 plus 7. Okay, and which equals to 24. So mean deviation about the mean is 24 upon 8, and this is simply equal to 3. Therefore, mean deviation about mean is equal to 3, and this is our final answer. So I hope this question is clear to all of you, and now let's move to the next question. This question asks us to find the mean deviation about the mean for the below given data. Okay, so the data set given is 38, 70, 48, 40, 40, 42, 55, 63, 46, 54, 44. So first of all, try it yourself. The question is to find the mean deviation about the mean for the given below data. So the given below data is given in below. Okay, and so now we will solve this question step by step. So first of all, let's write down the data set we are working with. So the data set is 38, 70, 48, 40, 42, 55, 63, 46, 54, and 44. Okay. Now let's recall the formula for the mean. So the mean x bar equal to summation I equal to 1 to n xi divided by n. So summation I equal to 1 to n xi, it means sum of the given data, okay, and divided by total number of data points. So x bar, this is equal to 38 plus 70 plus 48 plus 40 plus 42 plus 55 plus 63 plus 46 plus 54 plus 44 divided by 10. So sum of these data points is 500. So x bar equal to 500 divided by 10, and it is equal to 50. Next, we need to find the absolute deviations of each observation from the mean. So for each xi, we calculate the absolute value of xi minus x bar, and these values are mod of 38 minus 50 equal to 12 for 38. For 70, it's mod value of 70 minus 50 equal to 20. For 48, it is mod value of 48 minus 50 equal to 2, and for 40, it is mod value of 40 minus 50 equal to 10. Similarly, you can find the absolute deviations of the remaining observations from the mean x bar, okay, and the values are in the below. Okay, so here for the data 42, absolute deviation is mod of 42 minus 50 is 8. For 55, it is mod value of 55 minus 50 equal to 5, and for 63, it is mod value of 63 minus 50 equal to 13. For 46, it is mod value of 46 minus 50 equal to 4. So similarly, you can find the for data 54, for data 44. Okay, so here we know mean deviation about the mean formula is given by summation from I equal to 1 to n modulus value of xi minus x bar divided by n. Here n is 10 and x bar is 50. Therefore, mean deviation about the mean is summation I equal to 1 to 10 absolute value of xi minus x bar divided by 10. Here sum of the given data points is 12 plus 20 plus 2 plus 10 plus 8 plus 5, okay, plus 13 plus 4 plus 4 plus 6. This is basically sum of absolute deviations, okay, and divided by number of data points, that is 10. So adding these up gives us a total of 84, and so our calculation is mean deviation is 84 upon 10 equals 8.4. Therefore, mean deviation about the mean is 8.4, and this is our final answer. So now let's move to the next question. In this question, we have to find the mean deviation about the median for the given below data. So the given data are 13, 17, 16, 14, 11, 13, 10, 16, 11, 18, 12, 17. So for solving this question, first of all, we have to find median for the given below data. Okay, and then we can find the mean deviation about the median by taking absolute deviations of the given data from the median. Okay, so first of all, try it yourself. So let's solve this question step by step. The given data is 13, 17, 16, 14, 11, 13, 10, 16, 11, 18, 12, 17. Here, the numbers of observation is 12, which is an even number. Now, let's arrange the data in ascending order. So this means we list the numbers from smallest to largest. Okay, so the rearranged order will be 10, 11, 11, 12, 13, 13, 14, 16, 16, 17, 17, 18. Since we have an even number of observations, so the median is found by taking the average of the n by 2th observation and n by 2 plus 1th observation. So the formula is median m equal to n by 2th observation plus n by 2 plus 1th observation divided by 2. Here n is the total number of data points. Now let's substitute our value of n, which is 12, into the formula. So median m, this is equal to 12 by 2 plus 12 by 2 plus 1th observation divided by 2. Now let's identify those observations. So here are the median m is basically 6th observation plus 7th observation divided by 2. So by calculating, by finding 6th observation and 7th observation, we get median m equal to 13 plus 14 divided by 2, and this is equal to 27 upon 2, and this is equal to 13.5. So median is 13.5. Now let's find the absolute deviations of each observation from the median. So the absolute value of 13 minus 13.5 is 0.5. Absolute value of 17 minus 13.5 is 3.5. Absolute value of 16 minus 13.5 is 2.5. And absolute value of 14 minus 13.5 is 0.5. Similarly, you can find the absolute value of 11, 13, 10 and 16 from the median 13.5. So we know mean deviation about the median is summation from I equal to 1 to n absolute value of xi minus m divided by n, where m is the median, n is the total number of observations. Therefore, mean deviation about the median is equal to summation I equal to 1 to 12 absolute value of xi minus m divided by 12. Now let's substitute the values into the formula. So we add up all the absolute deviations: 3.5, 2.5, 2.5, 1.5, 0.5, 0.5, 0.5, 0.5 4 times, and then 2.5, 3.5, 3.5, and 4.5. So if we add these absolute deviations, then you will get some numbers, okay, and then divide that numbers by 12. So after adding all those numbers, we get 28. So mean deviation is 28 divided by 12, which equals 2.33. Therefore, mean deviation about the median is 2.33. So I hope this question is clear to all of you and you are getting my point. So now let's move to the next question. The question asks us to find the mean deviation about the median for the given below data. So the data is 36, 72, 46, 42, 60, 45, 53, 46, 51, 49. Okay. So students, first of all, try it yourself. So the question is to find the mean deviation about the median for the given below data. So let's restate the data we are working with. So the data is 36, 40, 36, 72, 46, 42, 60, 45, 53, 46, 51, 49. Here the number of observation is 10, which is an even. Now let's arrange the data in ascending order. This means we list the numbers from smallest to largest. So the order of the numbers will be 36, 42, 45, 46, 46, 49, 51, 53, 60, 72. To find the median when n is even, we use this formula: median equal to n by 2th observation plus n by 2 plus 1th observation divided by 2. So let's substitute our value of n, which is 10, into our formula. So median, this is equal to 10 by 2th observation plus 10 by 2 plus 1th observation divided by 2. This means median is 5th observation plus 6th observation divided by 2. Now let's find 5th observation and 6th observation. So 5th observation is 46 and 6th observation is 49. So average of 46 and 49 is basically 46 plus 49 divided by 2, and this is equal to 95 upon 2, and this is equal to 47.5. So median is 47.5. Now first let's focus on finding the absolute deviations of each observation from the median. So this means for each number in our data set, we will subtract the median and take the absolute value. Okay, so the notation for this is absolute value of xi minus m. Okay, and the absolute deviations of the respective observations from the median are: for 36, absolute deviation of 36 minus 47.5 is 11.5, and absolute difference of 42 minus 47.5 is 5.5. Absolute difference of 45 minus 47.5 is 2.5. Similarly, you can find for 46. So we have absolute value of 46 minus 47.5 is 1.5, and you can find for remaining data. Okay, so notice how each numbers get farther from the median. The observations increase here. So finally, for the last number 72, the deviation is absolute value of 72 minus 47.5, and this is equal to 24.5. And we know that mean deviation about the median is summation I equal to 1 to n absolute value of xi minus m divided by n. Therefore, mean deviation about the median is summation I equal to 1 to 10 absolute value of xi minus m divided by 10. So here we substituted the value of n is 10. Okay. Now let's add up all the absolute deviations. 11.5 plus 5.5 plus 2.5 plus 1.5 plus 1.5 1 plus 1 by 1.5 plus 3.5 plus 5.5 plus 12.5 plus 24.5. Okay, and then we will divide this total by 10 to find the mean deviation. Adding up all those deviations gives us 70. So mean deviation about the median is 70 divided by 10, which equals 7. Therefore, mean deviation about the median is 7. So I hope this question is clear to all of you. So now let's move to the next question. So let's see question number 5. So in this question we have asked to find the mean deviation about the mean for the given below data in the table. So the table shows two rows. In first row shows xi, the values of xi like 5, 10, 15, 20, 25, and in second row it shows the frequency if I. Okay, so first of all try it yourself. So here first of all look at the given table, okay, and then find the mean deviation about the mean using the given table. So let's solve this question step by step. First of all, we know mean deviation about the mean is 1 by n summation I equal to 1 to n fi multiplied with my absolute value of xi minus x bar. Now let's organize our data in a table to make calculations easier. So we will list xi, fi, and then calculate fi times xi for each row. So here in the look at this table. Okay, here is the completed table. So xi values are 5, 10, 15, 20, and 25, and their frequencies fi are 7, 4, 6, 3, 5 respectively. Okay, and then we get fi multiplied with xi values of 35, 40, 90, 60, and 125, and then adding up all the frequencies. So n equals to summation I equal to 1 to 25, fi equal to 25, and adding up all the fi xi, the total is 350. So this sets up to calculate the mean in the next step. From table, we get n equal to summation I equal to 1 to 5 if I equal to 25, and summation I equal to 1 to 5 if I multiplied with xi is 350. Therefore, x bar equal to 1 by n multiplied with summation I equal to 1 to 5 if I multiplied with xi. So this is equal to 1 by 25 multiplied with 350, and this is equal to 14. So x bar equal to 14. Now finally, using x bar equal to 14, we now can move on to the next step. So we will use this mean to find the absolute deviations of each data value from the mean, which is needed for the mean deviation calculation. So in this table, here we calculated absolute deviations xi minus x bar, and then we multiplied fi with absolute value of xi minus x bar. Okay, so look at this table very carefully and see the data. Okay, so here you can see n equal to 25, summation a phi xi is 350, and here summation I equal to 1 to 5, a phi multiplied with xi minus x bar is 158. From table, we have n equal to summation I equal to 1 to 5, a phi is 25, summation I equal to 1 to 5, a phi multiplied with xi minus x bar is 158. Therefore, mean deviation about median is equal to 1 by n summation I equal to 1 to n a phi multiplied with xi minus x bar. This is equal to 1 by 25 multiplied with 158, and this is simply equal to 6.32. So I hope this question is clear to all of you. So now let's move to the next question. So let's examine a question about mean deviation, which is a measure of how much the data values differ from the mean. Okay, so the table shows two rows. The first row shows the values of xi, and the values of xi are 10, 30, 50, 70 and 90. Okay, and the second row shows their corresponding frequencies fi, and they are 4, 24, 28, 16 and 8. So first of all, try it yourself and then see the solution. So we will solve this question step by step. First, let's recall the formula for mean deviation about the mean. So it is mean deviation is equal to 1 by n multiplied with sum of a phi times the absolute value of xi minus x bar, where where I equal to 1 to n. Okay, and here n is the total number of frequency, that is summation if I equal to 1 to n. Okay, and xi is basically each data value, and x bar is the mean. So now let's organize our data in a table to make calculations more easier. So we will list each xi value here, its corresponding frequency fi, and then calculate fi times xi for each row. Okay, and this will help us find the mean in the next step. Okay, so look at this table. So in this table, here we have listed the values of xi, and the values of xi are 10, 30, 50, 70 and 90, and the values of fi are 4, 24, 28, 16 and 8, and then we find fi times xi. Okay, they are 40, 720, 1400, 1120 and 720, and at last we adding up all the frequencies fi, and we get here n equal to summation I equal to 1 to 5 if I equal to 80, and we add up all the fi xi from I equal to 1 to 5, that is 4000. So from table we have n equal to summation I equal to 1 to 5 if I is 80, and summation I equal to 1 to 5 if I times xi is 4000. Now let's use these totals to find the mean, so which we write as x bar. So the formula is x bar is 1 by n times sum of a phi into xi from I equal to 1 to 5, and here we substitute the values of n and summation I equal to 1 to 5 a phi xi. Okay, and we get here x bar equal to 1 by 80 multiplied with 4000, and this is equal to 50. Next, we will use this mean value x bar equal to 50, and to calculate the mean deviation, so we will need to find the absolute difference between each data point xi and the mean, and then multiply by the corresponding frequency. So look at this table. Here the first column is xi, the data values. The second column is fi, the frequencies. The third column is fi xi, which we have already summed to get 4000, and the fourth column is the absolute differences, absolute value of xi minus x bar. Okay, and the fifth column is for fi times absolute value of xi minus x bar. Okay, after we add up all the data, we get n equal to 80. Summation a phi xi I equal to 1 to 5 is 4000, and summation I equal to 1 to 5 if I multiplied with xi minus x bar is 1280. From table, we have n equal to summation I equal to 1 to 5 a phi is 80, and summation I equal to 1 to 5 a phi multiplied with xi minus x bar is 1280. So let's use the formula for mean deviation about the mean. The formula is mean deviation is equal to 1 by n multiplied with summation I equal to 1 to 5 if I multiplied with absolute value of xi minus x bar. So here we substituting our values, we get mean deviation is equal to 1 by 80 multiplied with 1280. Okay, and this is simply equal to 16. So this is our final answer. So I hope this question is clear to all of you. And now let's move to the next question. Now we will look at question number 7. So let's examine our question about finding the mean deviation about the median for the given below data. So the table shows two rows. In first row, the values of xi, and they are 5, 7, 9, 10, 12 and 15. And the second row shows the values of fi, and here fi basically frequency of the corresponding data, and they are 8, 6, 2, 2, 2 and 6. So first of all, try it yourself. How would you approach this question? So let's see here. In this question, we are given a frequency distribution table with values xi and their corresponding frequencies fi. So let's solve this question step by step. First, let's observe that the xi values, which are 5, 7, 9, 10, 12 and 15, and here you can see the values of xi are already in ascending order. So now adding a column corresponding to cumulative frequencies of the given data, so we obtain the following table. So we are given a frequency distribution table with values xi and their corresponding frequencies fi, and then we added a column corresponding to cumulative frequencies of the given data, and we obtain this table. Okay, so in the first column we have the values of xi, and in second column we have their corresponding frequencies, and in third column we have cumulative frequencies of the given data. First, we need to find total number of observations, which we call n. So we do this by adding up all the frequencies. So n equal to summation I equal to 1 to 5 if I, and this is equal to 26, which is an even number. Since n is even, the formula for the median in a discrete frequency distribution is median equal to n by 2th observation plus n by 2 plus 1th observation is divided by 2. Therefore, median is the mean of 13th and 14th observations. So both of these observations lie in the cumulative frequency 14, for which the corresponding observation is 7. Therefore, the median is the average of the 13th and 14th observations. So both the 13th and 14th observation fall within the group where xi is 7. So the median is 7 plus 7 divided by 2, and this is simply equal to 7. Now let's calculate the absolute deviations from the median. So for each data points xi, we subtract the median and take the absolute value. Okay, so mod of xi minus m. Here m is the median, which we have found to be 7. Okay, so we will do this for each value of xi and to calculate the absolute values of the deviations. So the absolute values of the deviations from median are, here you can see absolute deviation from median. Okay, so absolute values of deviations are calculated in a table in first column. Okay, in second column we have their corresponding frequencies fi, and in third column we multiplied fi with absolute values of deviations from median. So from table we have n equal to summation I equal to 1 to 6 if I. So this is equal to 26, and summation I equal to 1 to 6 if I multiplied with absolute values of xi minus m. This is equal to 84. Now let's recall the formula for mean deviation about the median. So the formula is mean deviation is equal to 1 by n multiplied with summation of I equal to 1 to n if I multiplied with absolute value of xi minus m, where n is the total frequency, if I is the frequency of each value xi, okay, and xi is each value, and m is the median. So we have mean deviation is equal to 1 by 26 multiplied with 84. When we calculate this, we get mean deviation is 3.23, and this is our final answer. So I hope this question is clear to all of you. So now let's move to the next question. So look at question number 8. So in this question we have to find the mean deviation about the median for the given below data. So in the table, in first row we have the values of xi, and in second row we have their corresponding frequencies. Okay, so first of all, see the table very carefully, and using the given data find the mean deviation about the median. So first of all, try it yourself. So let's solve this question step by step. So first, let's check if the xi values are in ascending order. Okay, so we see that the values are 15, 21, 27, 50 and 35. Okay, so we have to arrange this data in ascending order. So now let's add a column for cumulative frequencies, which we will call C. Okay, Notice in the table, xi values are 15, 21, 27, 30 and 35, and their frequencies are 3, 5, 6, 7 and 8, and we will solve this step by step. So next, let's find the total number of observations. So we call it n. So we add up all the frequencies and we obtain the value of n. So n equal to 3 plus 5 plus 6 plus 7 plus 8, and this is equal to 29. Since 29 is an odd number, so we emphasize here the type of n. Okay, so n is an odd number. Therefore, median is equal to number of observation plus 1 by 2th observation. Okay, this is equal to 29 plus 1 by 2 8th observation, and this is simply 15th observation. So median is 15th observation. So now let's try to find which number is the 15th observation. So this observation lies in the cumulative frequency 21, for which the corresponding observation is 30. Therefore, the median of this data set is 30. First, let's focus on finding the absolute deviations from the median. So the absolute values of the deviations from median, that is absolute value of xi minus m, and here m is 30, are mod of xi minus m are 15, 9, 3, 0 and 5. Okay, and here in second column of this table we have corresponding frequencies fi. The values of fi are 3, 5, 6, 7 and 8, and then we multiplied fi with absolute values of xi from median m. Okay, and the values of fi multiplied with xi minus m are 45, 45, 18, 0 and 40. So now let's sum up frequencies and the products. Okay, and the total frequency n is the sum of all fi, where I equal to 1 to 5. Okay, so n equal to 29, and then the sum of fi multiplied with xi minus m is 148. Okay, so these totals are important because we will use them to calculate the mean deviation in the next step. So now let's recall the formula for mean deviation about the median. The formula is mean deviation about the median is equal to 1 divided by n into sum of fi times the absolute value of xi minus m, where n is the total frequency, fi is the frequency of each value, and xi each data point, and mi is the median. Next, let's substitute the values from our table into the formula. The total frequency n is equal to 29, since 3 plus 3 plus 5 plus 6 plus 7 plus 8 is 29. So our formula becomes mean deviation about the median is 1 divided by 29 multiplied with sum from I equal to 1 to 5 a of a5 multiplied with x absolute value of xi minus m. Finally, after calculating the sum of fi times the absolute value of xi minus m, we get 148. So mean deviation about the median is 1 divided by 29 multiplied with 148, which equals approximately 5.1. Okay, and this is our final answer. So I hope this question is clear to all of you. And now let's move to the next question. Look at question number 9. So let's examine a grouped frequency distribution problem where we are asked to find the mean deviation about the mean. Okay, so the table shows income per day in rupees in first column, and in second column number of persons. Okay, and we have to find the mean deviation about the mean. So first of all, try it yourself and then see the solution. So we have to find mean deviation about the mean for the given below data. So let's solve this question step by step. So mean deviation about the mean is given by the formula mean deviation is equal to 1 divided by n multiplied with fi times the absolute value of xi minus x bar. Here n is the total number of persons, fi is the frequency for each group, and xi is the class mark for each group, and x bar is the mean. Now let's recall how to find the class mark xi for each group. So the class mark is calculated as xi equal to x1 plus x2 upon 2. Now we have added a new table with more details. Here fi stands for the frequency, which is the number of persons in each income group. xi is the midpoint of each income range and calculated as lower limit plus upper limit divided by 2. The column fi xi is the product of the frequency and the midpoint for each group, and we will use these values to find the mean using the formula. So mean is basically sum of fi xi divided by sum of fi. So let's pay attention to how each value is calculated. Okay, so look at here, sum of the number of persons, total number of persons is basically f1 plus f2 plus dot 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 plus f8. Okay, so n equal to summation I equal to 1 to 8 fi, and the total of frequency is basically 50. So n equal to 50, and here summation fi xi from I equal to 1 to 8 is 17,900. Here n is equal to summation I equal to 1 to 8 fi is equal to 50, and summation I equal to 1 to 8 fi times xi is 17,900. Now let's recall the formula for a mean of group data. So the mean written as x bar is given by x bar equal to 1 divided by n multiplied with summation I equal to 1 to n fi times xi. Here x bar represents the average income per day. Okay, and n is the total number of persons, and sum of fi xi is the total of each group frequencies multiplied with its mid value. Therefore x bar equal to 1 divided by 50 multiplied with 17,900, and after calculating you will get this is equal to 358. Now we will add column absolute deviations of xi minus x bar. and then we will multiply fi with absolute difference of xi minus x bar, where x bar is 358. So the new table will be look like this. Okay, so this is our new table, and here we added column absolute value of xi minus x bar and fi multiplied with absolute value of xi minus x bar. And here look at the bottom of the table. N equal to summation I equal to 1 to 8 if I, and this is 50, and summation I equal to 1 to 8 if I times xi is 17,900, and summation I equal to 1 to n if I times absolute value of xi minus x bar is 7,896. Now, let's recall the formula for mean deviation about the mean. So, it is written as mean deviation is equal to 1 divided by n times sum of fi times absolute value of xi minus x bar, where n is the total number of persons, fi is the frequency for each class, xi is the class mark, and x bar is the mean. So, in this question, here we have already calculated that n, the total number of persons, is 50, and sum of all fi times absolute value of xi minus x bar comes out to 7,896. Therefore, mean deviation about the mean x bar equal to 1 divided by n summation I equal to 1 to 8 fi times absolute value of xi minus x bar is equal to 1 by 50 times 7,896, and when we multiply this out, we get 157.92. Okay, and this is our mean deviation about the mean. So I hope this question is clear to all of you. So now let's move to the next question. Look at question number 10. So in this question, we have to find the mean deviation about the mean for the given below data. Okay, so the table shows two rows. The first row lists height in centimeters, and in the second row shows number of boys in the each class of height in centimeters. Okay, so first of all, try it yourself and then see the solution. So the question asks us to find the mean deviation about the mean for a set of height data. So notice the table, it shows height intervals in centimeters and the number of boys in each interval. So we will use this data to calculate the mean deviation step by step. So first, let's recall the formula for mean deviation about the mean. It is mean deviation about the mean is equal to 1 divided by n multiplied with sum of fi times absolute value of xi minus x bar, where n is the total number of observation and fi is the frequency of each class, xi is the midpoint of each class, and x bar is the mean. So where let's recall how to calculate the class mark xi. So xi is basically x1 plus x2 divided by 2. Here is the completed table with all the midpoints and the products of frequency and midpoint. Okay, so for each class we have listed the height interval, the number of boys, and here we added midpoint column and fi into xi column. Here n equal to summation I equal to 1 to 6 a5, and this is equal to 100, and summation I equal to 1 to 6 a5 into xi is 12,530. Therefore x bar equal to 1 divided by n summation a5 into xi, where I equal to 1 to 6, and here n equal to 100, so x bar equal to 1 by 100 times 12,530, and this is simply equal to 125.3. Now we will add column more absolute difference of xi minus x bar and a5 times absolute difference of xi minus x bar, where x bar is 125.3. So the new table will be look like this. So this is our new table, and here we added absolute value of xi minus x bar, this column, and a5 times absolute value of xi minus x bar, this column. Okay. The mean deviation about the mean is given by x bar equal to 1 by n summation I equal to 1 to n a5 times x absolute value of xi minus x bar. Here n is 100 and summation I equal to 1 to 6 a5 times absolute value of xi minus x bar is 1128.8. Mean deviation about the mean is equal to 1 by n summation I equal to 1 to 6 a5 times absolute value of xi minus x bar, this is equal to 1 by 100 times 1128.8, and this is equal to 11.28. Therefore mean deviation about the mean is 11.28. So I hope this question is clear to all of you. That's all for today's lecture, and thank you for your attention. I hope this lesson was helpful to all of you.